But what if I told you we can still harness that energy? You see, Einstein's mass-energy equivalence tells us that mass and energy are two sides of the same coin. The energy from the Big Bang didn't go away, it just changed forms, becoming matter and everything we see around us. But it's possible to turn that matter back into energy. How much energy? Einstein's famous equation gives us the answer. So what do E, M, and C squared actually mean? E stands for energy. What is energy?
It surrounds us, penetrates us. It binds the galaxy together.
And drives them rushing apart. It's described as the ability to do work or exert force. Usually we think of electrical energy, like when you plug in a lamp. The electrical energy from the wall goes into the bulb, which produces light, radiant energy, and heat, thermal energy. But while energy may change forms, it cannot be created or destroyed. See, there are many types of energy, but it all falls into two categories: kinetic or potential. Kinetic energy is movement, physical force. This includes heat, because thermal energy is just the movement of atoms. But electricity and light are forms of potential energy, as are gravity and magnetism. Potential energy is the force created by something's position in a field, like your proximity to a magnet, or to a planet's gravity. So now in our equation, energy is equal to m times c squared. So what's m? M stands for mass. Mass is the amount of matter in an object. The more matter it has, the heavier it is. We measure mass in kilograms, but unlike weight, mass is not affected by gravity. Although you might weigh more on Jupiter and less on the moon, your mass, or the amount of stuff that makes up you, stays the same. Almost everything has mass, even something as tiny as an atom. The periodic table lists all of the atoms from lightest to heaviest, and all of the stuff around us is made up of these atoms. Atoms, in turn, are all made of the same stuff: neutrons, protons, and electrons. The lightest element, hydrogen, only has one proton and one electron, whereas a heavier element like uranium has way more particles, so it's denser and has more mass. So now, to convert mass into energy, we multiply it by c squared. C refers to the speed of around 300,000 kilometers per second. That's fast enough to fly around the Earth 7 times in 1 second. This is insanely fast. It's so fast that nothing can go any faster. It's the cosmic speed limit, as Einstein discovered in his special theory of relativity. So anyway, this number is huge. And c squared is c times c. That number is, well, what's bigger than huge?
Astronomical.
I would have got there eventually. So now, converting mass to energy using E equals mc squared, you have to multiply m by this ridiculous number. So let's fill in this equation. Let's see how much energy we can get from a 1-gram paperclip. We multiply it by the speed of light squared, which gives us almost 90 million megajoules. How much energy is that? That's enough thermal energy to boil Lake Tahoe, or enough kinetic energy to launch nearly 2 tons at over 1 million kilometers per hour. All that energy from just a single paperclip. Now, what about something with more mass? If we took 1 kilogram of mass, like say this cantaloupe, and turned it all into electrical energy, it'd be enough to power Ireland for a year. Or if Gambit turned a 96-gram deck of playing cards into pure kinetic energy,
Look at the draw, my Shelly.
you'd have an explosion over 130 times more powerful than the Hiroshima nuclear blast.